Complex fractions are just fractions that include fractions in the numerator and denominator. To simplify complex fractions, we can either rewrite them as a division problem, or we can find the least common denominator, multiply everything by the least common denominator, and that will help simplify the expression a little bit and make it more manageable. Okay, we're gonna look at examples of both types. So in previous sections, we simplified rational expressions by factoring the numerator and denominator and canceling the common factors. When the rational expression contains fractions, either in the numerator and or the denominator, the process of simplification is different. Okay, in this section, we will cover complex rational expressions. So what is a complex fraction? A complex fraction is a rational expression in which the numerator or denominator, or sometimes both, contain a fraction. So a fraction divided by a fraction, or a sum of fractions divided by a fraction. Any number of fractions in a numerator, any number of fractions in your denominator. Boom, that makes it complex. Okay, so examples of some complex fractions. 1/2 divided by 3. That's a pretty simple one, but it's a complex fraction. 1/2 is a complex fraction. 5/7 divided by 2/3. So that's a fraction where your numerator and denominators are fractions. Those are all just numerical expressions that show you what complex fractions are, but we can also have algebraic complex fractions, so with x's. Okay, so if you look at examples A, B, C, and D here, they look crazy, I know, especially C and D. But when we rewrite these, you'll realize that they're not as bad as they look. We've already actually learned the skills that we need to solve these types of problems. It's just more about rewriting the problem to view it in a more manageable way, okay? So something like x over 3 over xy over 7. That's just x over 3 divided by xy over 7. So you'd set that up as a division problem and solve. Same for the next one, x over x minus 7 over 2x over x squared minus 49. We can just write that as x over x minus 7 divided by 2x over x squared minus 49. If the problem was written this way, we know how to solve that. We talked about division 2 classes ago. We just did an example with division. So for some of these problems, it's just a matter of rewriting it to a form that looks more familiar to us. And then for some of them, they are a little bit more challenging and we have to use a different technique to solve, okay? So we'll use 2 methods to simplify. Like I said, writing the expression as division, that's what I just showed you guys for part C there. And then the other one is using the LCD. So first, the steps for solving a complex fraction by writing it as division. Step 1, you want to simplify your numerator and denominator as much as possible. So sometimes your numerator might just be one expression. Sometimes you might have 2 fractions that are being subtracted or added. Whatever the case, you want to look at the numerator and simplify it as much as possible. If you have 2 fractions being added in a numerator, add them, combine it to 1 fraction, okay? Once you get to the step where you have 1 fraction divided by 1 fraction, then you rewrite the problem to look more like division. So basically just using different division notation. And we do keep, change, flip. Then use what we learned when we talked about dividing rational expressions to simplify. Okay. The easiest type of example we can see is what's shown here with 2 over 3 divided by 5 over 7. The numerator and denominator are simplified. Then we can just rewrite this using our other division notation. It's the numerator divided by the denominator. So 2 over 3 divided by 5/7. And we know that dividing by 5/7 is the same as multiplying by the reciprocal of 5/7. So this is 2 over 3 times 7 over 5, which is 14 over 15. So it's literally just rewriting using our different division notation. All right, some examples are done here for us. I do want us to look at a couple of them, and then we'll jump into the practice problems where we do some of these are on our own. Example 1 is solved for us. So let's look at Well, first I want to start off by showing you how to rewrite these. For problem A, x over 3 over x, y over 7. This would be x over 3 divided by xy over 7. And then from here, just do the same thing that we learned with division. Doing keep, change, flip, this would be x over 3 times 7 over xy. And then from here, we would want to cancel any common factors. We can cancel this x with this x. And our final answer would be 7 over 3y. That's it. Part B, this is the one I rewrote earlier. 7x over x minus 7 over 2x over x squared minus 49. If we write it as x over x minus 7 divided by 2x over x squared minus 49, then we can do keep, change, flip. It's x over x minus 7 times x squared minus 49 over 2x. Then what do we do with these types of problems? Factor as much as you can, cancel out any common factors, and multiply. This would be x over x minus 7 times x plus 7 times x minus 7 over 2 times x. So I'm going to use a different color to cancel. 1, we can cancel out the x minus 7s. We can also cancel out an x. And then we would be left with x plus 7 over 2 as our answer. All right, I'll pause really quickly. So again, what are we doing here? We're taking the fraction or the complex fraction and rewriting it using our other division notation, the numerator divided by the denominator, then do keep, change, flip, and use our techniques that we learned for multiplying fractions to simplify. All right, now for something like part C, these are the more challenging ones, but they're still doable. If you look at C, we have x over x plus 2 in our numerator, and then in the denominator, 2 over x squared plus 5x plus 6 minus 1 over x. There's a lot going on in that denominator. Before we rewrite this, we want to try to simplify the denominator. So let's just look at the denominator on its own. It's a subtraction problem. Just want to make sure I have enough room. I got to run out of room or space over here, so we'll go to the side. The numerator is going to stay exactly the same for right now. We're not changing anything. That denominator is 2 over x plus 2 times x plus 3 minus 1 over x. So we have to find a common denominator. The common denominator would be x times x plus 2 times x plus 3. Okay, or x times x squared plus 5x plus 6. So we need to multiply this first fraction because we're having x plus 2 and an x plus 3. We need an x. So we'll multiply by x in the numerator and x in the denominator. Oops. And for the second expression, we need to multiply by the x plus 2 times x plus 3 in the numerator and denominator. All right. So what does this become? Our numerator is x over x plus 2. That's not changing. In the denominator, our common denominator is x times x plus 2 times x plus 3. If we subtract those numerators, we get 2x minus, remember, x plus 2 times x plus 3 is just x squared plus 5x plus 6. And now that's over x times x plus 2 times x plus 3. All right, we're almost there, guys. One last thing before we can actually rewrite this. So to simplify what we have here, no, that doesn't, yeah. Okay, yeah, to simplify what we have here, in this numerator, still staying the same, we haven't changed anything with it. And now the denominator is, if we simplify that numerator, we'll get a negative x squared minus 5x plus 2x would be minus 3x, and then minus 6. And that's all over x times x plus 2 times x plus 3. All right, all of these steps were just to simplify the denominator. Now that we've simplified the denominator, we can rewrite this a little bit. This would be x over x minus 2 times, divided by negative x squared plus 3x plus 6 over x times x plus 2 times x plus 3. It doesn't look like anything cancels here. Let me make sure I didn't make any errors. I don't think I did. Nope, I believe me. All right, then this would be x over x minus 2 times x plus 2 times x plus 3 over negative x squared plus 3x plus 6. X squared plus 3x plus 6 does not factor. No. So then, yeah, there's nothing else we can do. We can multiply everything together, okay? And then that'll be our final answer. Ooh, excuse me. What is this? I'm sorry, you guys, give me 1 second. For the last couple of days, my computer has been turning against me. And all kind of random things have been popping up. Anyway, let me just get this off on my other screen and we'll be good to go. All right, where are we? Okay, I feel, oh, something does cancel out. I have a small typo here. I'm gonna highlight it and then fix it, and then we'll be done. So this is a x over x plus 2, x over x plus 2, x over x plus 2. And then for some reason over here, I wrote it as an x over x minus 2. So that should be a plus 2, plus 2, plus 2. Okay, then something does cancel out. This x plus 2 cancels with that x plus 2, and that's it. So we'll be left with x times x. So x squared times x plus 3 over negative x squared plus 3x plus 6. All right, yay! We've solved a tricky complex fraction. All right, and the only thing that made that one a little bit trickier is it wasn't just written as one fraction over one fraction. It was one fraction over a difference of fractions. So you have to simplify that denominator first, subtract the fractions in the denominator, and then rewrite it. All right, now that we've gotten a little bit of practice, we're gonna jump to the practice problems. For part A, we have 3 over 4 minus 2 over 7, all over 1/2 plus 15 over 14. To simplify this to simplify this complex fraction, we need to first simplify the numerator and denominator. So subtract the numerator, add in the denominator, and then we'll rewrite it. For 3 over 4 minus 2 over 7, the common denominator would be 4 times 7, 28. So we'll have to multiply this fraction by 7 over 7 and this one by 4 over 4. That gives us 21 over 28 minus 8 over 28 in the numerator. And then in the denominator, we have 2 and 14. So 14 would be the least common denominator. We'll have to multiply the first fraction by 7. And this gives us 7 over 14 plus 5 over 14. Then that simplifies to, what's this? 21 minus 8 would be 13. 13 over 28 in the numerator, and in our denominator, 12 over 14. And then finally, if we write this as division, it would be 13 over 28. Well, not finally, we have a couple of steps. Times, or divided by 12 over 14. It's like I can finish here, which is 13 over 28 times 14 over 12. And then the last step here would just be to simplify anything in the numerators with anything in the denominators. We can simplify the 14 and the 28. 14 divided by 14 is 1. 28 divided by 14 is 2. So finally, this would be 13 over 24. All right, for part B. In this one, the numerator is already one fraction, the denominator is already one fraction, so we can jump straight to rewriting it. This would be a, or 2a over a plus 4 divided by 4a squared over a squared minus 16. So that's 2a over a plus 4 times a squared minus 16 over 4a squared. All right, then from here we need to factor. We have 2a over a plus 4 times a plus 4 times a minus 4 over 4 is 2 times 2 and a squared is a times a. 2 times 2 times a times a. And then stuff cancels. The a plus 4's cancel, 1 and 2 cancel, 1a cancels. So that would be a minus 4 over 2a. So, last one of these, 2 over x plus 5 over 3 over x minus 5 minus 1 over x squared minus 25. So before we can rewrite this, we need to simplify what's in our denominator. If you want, you can kind of come off to the side and simplify that. 3 over x minus 5 minus 1 over x squared minus 25. This is 3 over x minus 5 minus 1 over x minus 5 times x plus 5. So we need to get a common denominator, multiply this first expression by x plus 5 over x plus 5. Then what does that give us? We'll have 3x plus 15 minus 1, those are our numerators, over x plus 5 times x minus 5. And finally, that would be 3x plus 14 over x plus 5 times x minus 5. That's what the denominator simplifies to. So all of that is just simplifying the denominator. So from here, we'll say that this is equal to 2 over x plus 5 divided by 3x, yes, plus 14 over x plus 5 times x minus 5. Then we can rewrite this using division. So this is 2 over x plus 5 divided by 3x plus 14 over x plus 5 times x minus 5. Rewriting this as multiplication gives us 2 over x plus 5 times x plus 5. Times x minus 5 over 3x plus 15. All right, and then what cancels? The x plus 5 cancel. All right, that's our final answer. 2 times x minus 5 over 3x plus 14. So these have all been examples of simplifying complex fractions by rewriting it as division. Another technique that we can use for simplifying rational expression or complex fractions is to multiply everything by the LCD. All right, so that's our second method. So method 2, to multiply or simplify complex fractions by using the LCD. We first want to look at the complex fraction. So remember, it's fractions inside of fractions. Look at all of the denominators you have and factor them as much as possible. Then find the least common denominator for all of the denominators. And then you're going to multiply everything by the LCD. When you do this, lots of things will cancel out You'll get rid of some of the fractions, and it makes the problem a lot nicer to deal with. We're going to jump to the problems here, and these are the same ones we did before in example 1, but in example 2, we'll solve them using this new method, using the LCD. So for problem A, x over 3 times xy over 7. We look at these problems, the two denominators are 3 and 7. So the LCD is 21, 3 times 7. This technique tells us we want to multiply everything, the numerator and denominator, by the LCD. So we're going to multiply this numerator by 21 and this denominator by 21. What happens when we do that? When we multiply x over 3 by 21, 21 divided by 3 is 7. So the 3 in the numerator is going to cancel out. The numerator just becomes 7x, and the denominator, 21 over 7, gives us 3. So this would become 3xy. Boom, just by multiplying by the LCD, we got rid of the fractions in the numerator and denominator. And now we just have one rational expression. We can cancel out the x's. Don't cancel them that much. Cancel out the x's, and we have 7 over 3y. If you can easily find the LCD, this method works nicely, because once you multiply everything by the LCD, the problem looks a lot simpler. All right, using the same idea for part B. In part B, our denominators are x minus 7 and, well, let's just factor this so that you can see it. 2x over x plus 7 times x minus 7. Okay, so the LCD would be the x squared minus 49 part, x plus 7 times x minus 7. This technique tells us we want to multiply the numerator by x plus 7 times x minus 7, and the denominator by x plus 7 times x minus 7. We can see right away in a denominator that this is great. The entire second denominator is going to end up canceling out. Cool, okay? Or the bottom denominator, I should say. So those cancel out completely, and we're just left with a 2x in the denominator. And then in the numerator, the x minus 7s are going to cancel. So we'd be left with x times x plus 7. And then finally, this gives us x times x plus, oh wait, sorry, wrong color. X times x plus 7 in the numerator, and the denominator just has a 2x. Can we simplify more? Yes, we can cancel out the x's. And then last step, we're left with x plus 7 over 2 as our final answer. Okay. And then last one. Now, for a problem like part C, using this method, I think, is a lot better, in my opinion, than using the other method. You can always use either one. You should know both, and most of the time it doesn't matter which method you use. But for something like this, remember when we solved this the last time, we had to move that over a little bit. Sorry, just making a couple of edits. When we solved this the last time, we had to take that denominator, subtract the denominator first, and then rewrite it. So there are a lot of steps involved. If we use the LCD method here, once we multiply by the LCD, nice things happen. So first, let's rewrite this with everything factored. It's x over x plus 2 over 2 over x plus 2 times x plus 3, and then minus 1 over x. All right, so what is the LCD in this problem? If we look at the denominators, what factors do we have? We have an x plus 2, and this denominator, we have another x plus 2 that's already taken care of. We also have an x plus 3. and then we have a denominator of an x. So all of those have to be included in the LCD. So our LCD is x plus 2 times x plus 3 times x. Let's multiply all three parts by this. Every single part, x plus 2 times x plus 3 times x, and then another x plus 2 times x plus 3 times x. When you do this step, all of the denominators should cancel out. Okay, so let's get a different color. In the numerator, our denominator was an x plus 2 that cancels with this x plus 2. In the denominator, for the first term, we have an x plus 2 that cancels with this one, and an x plus 3 that cancels with this one. And then the x here cancels with this x. So what are we left with? At the top, we're left with x times x plus 3 times another x. So x squared times x plus 3. And down in the bottom, we're left with 2 times x minus x plus 2 times x plus 3. So that would be minus x squared plus 5x plus 6. And I got this by foiling this part out. All right, last step. Our last step is just going to be to simplify that denominator a little bit. I don't think anything else is going to cancel out. So we have an x squared times x plus 3 over 2x minus x squared minus 5x plus 6. That would be a negative x squared minus 3x minus 6. You can leave it like that, or you can factor out a negative from the denominator. I can say, or it would be negative x squared times x plus 3 over x squared plus 3x plus 6. You can write it either way. All right. So again, either of these methods can work for any complex fraction. Most of the time, it doesn't matter which one you use. But if you can find the LCD for a problem like Part C, I think this method is a little, to me, in my opinion, this method is a little bit nicer, because once you multiply by the LCD, all of the denominators. For a problem, practice exercise 2, Part A. If we look at our denominators here, we have a denominator of 4, 7, and then 2 and 14, which is 2 times 7. I'm going to write that as 2 times 7. All right, then to find our LCD, we need every factor that appears. So we'll need a 2, we need a 4. Oh, actually, a 4 already contains a 2. So we really only need the 4 and the 7. Why don't I need another 2? Because 4 is 2 times 2. So we need the 4 and the 7. Our LCD would be 28. What does this mean? We're going to take 3 over 4 minus 2 over 7 over 1/2 plus 5 over 14. We're going to take that and multiply every single term by 28. When we do this, our denominators should cancel out. 28 divided by 4 is 7, and 7 times 3 is 21. So this first term at the top becomes a 21. And then 28 divided by 7 is 4. 4 times 2 is 8. So we get 21 minus 8 in the numerator. So the denominator, 28 times 1/2 would be 14, and then plus 5 over 14 times 28. We would do 28 divided by 14 is 2, and then 2 times 5 is 10. And then finally, 21 minus 8 is 13. 14 plus 10 is 24. We get 13 over 24. All right, on to B. 2a over a plus 4 over a squared, 4a squared over a squared minus 16. A squared minus 16 is a plus 4 times a minus 4. So the LCD for this one would be the a plus 4 times a minus 4. That has all of the factors we need. If we multiply the numerator by this and multiply the denominator by a plus 4 times a minus 4, wonderful cancelizations happen. This a minus 4 cancels with this one. This entire denominator cancels with these. And then in the numerator, we're left with 2a times a minus 4. And in the denominator, we're left with 4a squared. All right. Then we can simplify this one a little bit more. The 2 and the 4 can be simplified, and one of the a's also can be simplified. So our final answer here, this cancels out, this becomes a 2. This cancels out, this becomes an a. Our final answer is a minus 4 over 2a. And last one. Our denominators are, this factors to x plus 5 times x minus 5. So x plus 5, x minus 5, and x plus 5 times x minus 5. So the LCD would be the x plus 5 times x minus 5. Right, I'm going to just rewrite this really quickly. 2 over x plus 5 over 3 over x minus 5 minus 1 over x plus 5 times x minus 5. If we multiply everything by the LCD, x plus 5 times x minus 5, that is not a 5. Then x plus 5 times x minus 5, x plus 5 times x minus 5. What happens here? In the numerator, the x plus 5s cancel. In the denominator, for the first term, the x minus 5s cancel. And then for the other term, everything cancels except the 1. All right, so we are left with 2 times x minus 5 over 3 times x plus 5 minus 1. All right, and we can simplify that a little bit. You could really leave it like this. It's not a huge deal. We can distribute in the numerator, but usually we say leave this in simplified form, but 2 times x minus 5, we can keep it like that. In the denominator, we can combine this or expand here because it's not just one term. That would be 3x plus 15 minus 1, so 3x plus 14.